In this lesson, students will be able to use square tiles to prove that area will remain the same when partitioned. They will use evidence to explain why area is conserved when partitioned. In earlier lessons, students have used arrays to represent equations and area models as a way to show how an area of a rectilinear shape may be determined. Using tiles and graph paper, a student may be asked to model an area of 24, beginning with the expression of 4 times 6. We see in this array that the 4 represents the horizontal row, and 6 represents the vertical column of the array. The student can represent this area model mathematically with the expression 4 times 6, or an equation of 4 times 6 equals 24. The student will be asked to partition and write a new expression for the same area. One way would be to partition the 6 as 3 plus 3 and write the expression for each area, 4 times 3 and 4 times 3. Now writing an equation of 4 times 3 plus 4 times 3. Each expression equals 12. The sum of 12 plus 12 equals 24. This is equal to our original 4 by 6 area model of 24. Another way to partition an area of 24 would be to rename the 6 as 1 plus 5. Naming the first area with the expression of 4 times 1 and the second area of 4 times 5, we can write 4 times 1 plus 4 times 5. 4 times 1 equals 4, and 4 times 5 equals 20. Writing the equation of 4 plus 20 equals 24. Now the student may write that 24 equals 24. And so 4 times 6 equals 4 times 1 plus 4 times 5. Thereby meeting the lesson objective of proving that an area remains equal no matter how it is partitioned. Let's look at one last way to model an area of 24. This time we'll partition the 4 and rename it as 2 plus 2. The 6 remains unchanged, and we can write an expression for each area, 2 times 6 and 2 times 6. Writing an equation, 2 times 6 plus 2 times 6, where the 2 times 6 equals 12 twice, and the sum of two 12s is 24. In this lesson, students use tiles to prove that even if an area was partitioned, that it remained the same. There are many ways a student can choose to partition or rename any number. Having the student using tiles and area models, they can make larger numbers easier to calculate mentally. These lessons are important in developing flexibility with numbers and number sense, and lead to a deeper understanding and application of the distributive property.